So why exactly did we decide to restore this beat-up fossil car? There's a not-so-ancient quote that goes along the lines of, you have to know the past to understand the present. Nowadays, it's safe to say that electric cars are revolutionizing the automobile industry. By working on the Sebring City car, which happens to be the first street-legal EV, we were able to break down and analyze the technology of the past and compare it to that of today's, learning about the what was to now what is. Our perspective has shifted as we are no longer outsiders looking in wondering about the what, but rather insiders exploring more complex ideas such as the why.
We began by splitting the work into different parts so we could more efficiently use our time and resources. Ian and Wazzy worked on the aesthetics and body of the car, while JP and Andrew focused on the electronic systems and brake lines. The electronics began with studying the wiring diagram and labeling all of the pre-existing components. Next, we wired two 24-volt batteries in series to create a 48-volt system and spent time troubleshooting with the distributor for the charger until we got it working. Most recently, we have mapped out and tested fitting relays onto the lights of the car, as well as completed modeling the dashboard. We are currently working to install the dashboard model into the car along with the various instruments for the 12-volt electronics. For the brake lines, we mapped out the path that the line should take, measuring the amount of line we would need with the string. Next, we began to take small parts of the line and bend it to fit the path, and are currently waiting for the flexible tubing to connect the hard line to the wheels.
Ian and Wazzy started on the aesthetic aspects of this car by completely stripping the car of its outer body shell and older parts that did not look properly made or done to our expectation. Then we began cardboard modeling for the open spaces adjacent to our floorboard. We also began creating new wheel wells that were made out of a sturdier piece of metal. After finishing the new wheel wells, as well as finishing the cardboard modeling, we took metal sheets to replace the models and utilized rivets to attach it all together. We then obtained our racer seats and began creating multiple mount setups for the seats. We finalized our mount setup on the third edition of designs, which now can store all the batteries and provide routes for wiring to travel through, while properly stabilizing the seats on top of it. We then reattached an edited trunk set.
This next photo shows one of my first drafts of the adapter plate. I was lining it up to the interior wall right there, making sure it would fit over and all of that. It's one of V1s. We ended up going through about 8 to 12 versions of it, just from simple edits or major edits, and we kept reprinting, and finally we got to the proper one, which is this version right here. This is our final version. We have all the holes. This is like the front end of it. This part goes into the transmission. All the holes line up properly. And then we have the other side of the adapter plate, which is our final version. This goes into the motor. It has all the cutouts we need, proper hole sizing and everything. This is what we will be using to get an actual metal version made by a professional.
To program the motor controller, we used the DVT software to input data found from the motor spec sheet, such as nominal voltage and rated speed. This software could also be used to monitor the status of the motor and make sure the accelerator was outputting the right voltage.
Finally, we have finished our work on the dashboard and we have received our flexible lines, so all that's left is to throw everything in the car.